So last class, we started stoichiometry and we learned how to do mole to mole conversions. So today we're going to learn mass to mass calculations. Okay. And so when we measure mass, like when you put something on the balance and you measure its mass, what unit is it in? Okay, grams. So that means for mass calculations, we're going to start in grams and we're going to end in grams. Okay. It's just this time we can use the mass of any reactant or product in grams, and we can use that to calculate the mass of any other reactant or product, also in grams. And so we have like this generic game plan we're going to follow. Okay, so when we do these calculations, we're going to convert from grams to moles to moles to grams. Okay, so copy that down. That's kind of our generic path we'll follow today. Okay, so the best way to learn how to do the mass calculations, we're just going to do a handful together. Go ahead and copy down this balanced equation again. Okay, we'll use this as our example, I think, for these first two problems. Okay, so we're going to calculate the number of grams of ammonia produced by the reaction of 5.40 grams of hydrogen with an excess amount of nitrogen. So we're going to start this problem just like we did the other day. So first we just have to organize our information. So what's the known quantity given to you? Okay, so it's the 5.40 and it's grams of, okay, so then I just like to list it below the hydrogen. So I know we have 5.40, and today our unit's gram, so I'm going to put the G there. And then when anything is worded as an excess amount of nitrogen, it just means you have enough nitrogen to react with this much hydrogen. So really, for all intents and purposes, you can just ignore the nitrogen for this problem. Okay. And then what are we solving for? This one we're looking for ammonia, so I'm going to put the question mark under the ammonia. And then this time, what unit are we trying to solve for? Okay, grams, so I'm going to put a G for grams. Okay, so these problems today, they're going to be longer than they were yesterday. So before we jump into the dimensional analysis, I'm going to make a game plan first. Okay. This one, are we going to start with hydrogen or ammonia? Okay, it's got to be the hydrogen because that's the one that has the number. And we're starting in grams. Okay, so we're going to start with grams of hydrogen. Okay. And we eventually have to get over here to where ammonia is. Do you remember from last class, what did we have to use to go from hydrogen to ammonia? Do you remember what we called it? Did I make you say it out loud? Good. Okay, so you have to use the mole to mole ratio. So that means what unit do you have to be in? Moles. Okay, so we're going to convert it to moles of hydrogen. Then once you're in moles of hydrogen, we can use the mole to mole ratio, and we'll convert to moles of ammonia. And then finally, what unit does your answer need to be in? Okay, so then our last step, we'll convert it to grams of ammonia. Okay, so do you see how we're going to follow this pattern, this grams to moles to grams pattern? Okay, so that's what's fitting that generic kind of game plan you wrote down on the previous slide. Okay, so now that we have a plan, can we do some dimensional analysis now? Okay, now we'll do our dimensional analysis. What number is going to go in your first box? Okay, so 5.40 grams. And make sure you put hydrogen in there. Also, when you write hydrogen, make sure you're getting the correct formula. Hydrogen is one of those diatomics, so make sure you're writing H2. All right, and then we're just going to follow our game plan. So here we are at grams, and we have to get to moles. What number do we use to convert between grams and moles? Okay, molar mass. And remember, hydrogen's H2. So what do you have to do to its molar mass? Okay, times it by 2. So what's 1.01 times 2? Okay, so hydrogen, it's 2.02 grams of hydrogen. And since it's molar mass, it's per mole, which is always 1 mole. And so then if we look at our units, grams of hydrogen cancel. So now we're here. We're at, oh, I thought it was my red dot. We're at moles of hydrogen and moles of hydrogen. Okay. So now we have to get to moles of ammonia. Okay. How do we get from hydrogen to ammonia? What do we use? Say it out loud. Okay, we're going to use the mole to mole ratio. Okay, so we're just using that 3:2 ratio. If moles of hydrogen is up top, what has to go on the bottom? Okay, it's got to be moles of hydrogen, and how many? 3. So we put 3 moles of hydrogen on the bottom. And how many moles of ammonia do you get?
2.
Okay, 2 moles of ammonia. Okay, so moles of hydrogen cancel. So now we're in moles of ammonia, which is right here in our plan. And we have to get to grams. So again, what number do you use to go from grams to moles? Molar mass. Great. Okay, so let's add up the molar mass of NH3. What's N? Okay. 14.01. And then what's 3 times 1.01? Okay, so then what's 14.01 plus 3.03? Good. Okay, 17.04. Let's check our unit. So moles of ammonia is up top. So what unit has to go on the bottom? Okay, and molar mass is always 1 mole. So then for every 1 mole of NH3, how many grams does it weigh? Okay, so we get 17.04 grams. Okay. So again, moles of ammonia cancel. The only units that don't cancel is grams of ammonia. And does that match what our answer needs to be in? Yes. Okay, so that's how you know when you're finished. Okay. So now it's time to multiply. This time, do you see how we have multiple numbers in both the numerator and denominator? Mm-hmm. Okay, I'd recommend multiply the top row straight across, get an answer. Okay. Then multiply the bottom row straight across, get an answer, and then divide them. Okay. So everybody practice typing this in your calculator. Make sure you know how to use your calculator and you know how to get the correct answer. Okay, anybody have an answer?
30.36.
30.36?
Yeah.
Are we getting 30.36? I see some nods.
Yeah.
30.36. Okay. Are we getting this?
Yeah.
Okay, good. Okay, last step, sig figs. And the good news, sig figs shouldn't be terrible when it comes to these. How many are in 5.40?
3.
Okay, 3. How about 2.02? 3. The whole numbers don't count. So then over here, 17.04. More than 3. So what should your answer have?
3.
Okay, so what would we round this to? Okay, so we get 30.4, and what's your unit? Grams of ammonia. Okay, this time, same equation. This time, let's figure out how many grams of nitrogen are needed to produce the 30.6 grams of ammonia. Okay. So let's say this time you make 30.6 grams of ammonia. This time, what are we solving for? Okay, grams of nitrogen. So again, I just like to put my question mark and a gram there, just so we know what we're looking for. And again, before we do dimensional analysis, I'd recommend just the game plan. Okay, so let's make sure we understand how we're going to convert before we actually try it. So what unit and which chemical are you going to start with? Okay, we're gonna start with ammonia, and we're gonna start in grams. Okay. So we know we're gonna start with grams of ammonia. And we have to get all the way over here to nitrogen. So what unit do you have to be in to do that? Okay, you have to be in moles. So that means we have to convert to moles of ammonia. Then from moles of ammonia, we can convert to moles of nitrogen. And then finally, what unit does your answer need to be in? Okay, and we'll go grams of nitrogen. Okay, so step one, make that game plan. If you aren't sure which units you're converting to, do you have much hope of like magically trying to get it right in dimensional analysis? Not really, right? So make sure, take the time and understand, make sure you know like what your conversions are gonna be. Now once you have a plan, then we can do the dimensional analysis part. What number goes in that top box? Okay, so we get 30.6 grams of ammonia. And how do we get from grams to moles? Okay, molar mass. Did we just calculate this one on the previous problem? Okay, so look back. What is the molar mass of ammonia? Okay, so 17.04 grams of ammonia is equivalent to 1 mole. Good. So now, what do you have to use to get from moles of ammonia to moles of nitrogen? All of you say it out loud. Okay, mole to mole ratio, and this time it's a 2 to 1. Okay. Which number has to go on the bottom?
2.
Okay, it's got to be 2 because it has to be the ammonia. So there's 2 moles of ammonia. And then what goes on the top?
1 mole.
Good. Okay, so 1 mole of nitrogen goes on the top. Okay, and then last step, we have to get to grams. How do you get from moles to grams? Okay, molar mass. What do you notice about nitrogen's formula? Okay, diatomic. So what do you have to do with its molar mass? Okay, double it. So what's the molar mass of N2? 28.02. Okay, and then let's look at units. If you have moles of nitrogen up top, what has to go on the bottom? Okay, it's got to be moles, and molar mass will always just be 1 mole. Okay, so for every 1 mole of nitrogen, it'll weigh 28.02 grams. Okay, then check your units. They should all cancel except your final unit, and that should match what your final answer needs to be in. Then practice calculating. So multiply that top row, get an answer. Okay. Multiply your bottom row, get an answer, and then divide them. Are you all getting 25.15? Okay, how many sig figs are in 30.6? Okay, 3, more than 3, 4, more than 3. So how many should your answer have?
3.
Okay, so what should we round that to?
25.2.
Okay, 25.2, and what's your unit? Good. Okay, copy this equation down. And then this one, it's my font, but this is calcium carbide, so it's like a lowercase a. The theme of the PowerPoint doesn't let you do a lowercase, okay? But this is like calcium carbide here. Okay, so this time we're going to figure out how many moles of calcium carbide are needed to completely react with 49 grams of water. So what's our given quantity? Okay, so we know we have 49.0 grams of water. And then what are we solving for? Okay, So moles of CaC2. So I just put the question mark there. And then I am going to write the unit moles, just so I don't take it one step further to grams. Okay, so I'm going to make my game plan again, just like we did on the previous two. Are you going to start with the calcium carbide or the water? Okay, water, because that's the one that you have the number for. And your unit's going to be grams. So this time we're starting with grams of water. And then what unit do you have to be in to get from water to the calcium carbide? Okay, so we'll have to convert that to moles of water. Then we can convert it to the moles of calcium carbide. And then what unit does your answer need to be in? Okay, moles. So this is where I'm going to stop this time. Okay, you with me here? Okay, so this one less step. So just make sure when you're reading problems, you just pay attention to units. Okay, don't just mindlessly go to grams every time. Okay, now that we have a plan, can we do our dimensional analysis? Okay. What number is going to go in that top box? Okay, so we're going to start with 49.0 grams of water. And how do we get from grams to moles? Okay, molar mass. If you look, we did molar mass of water for the warm-up. What is the molar mass of water? Okay, so 18.02 grams of water are in 1 mole of water. Then what do you have to use to get from moles of water to the moles of calcium carbide? Okay, that mole to mole ratio, if moles of water is up top, what has to go down here? Okay, and it's 2 because of this coefficient. Okay, so there's 2 moles of water. And then how many moles of calcium carbide do you use? Okay, so 1 mole calcium carbide. And then this time, my answer needs to be in moles, so this is where I'm going to stop. Okay, so now go ahead and multiply your top row, multiply your bottom row, and then divide those so you get your final answer. I don't know. Yes, I think that sounds right. Okay, we're getting 1.35. Yes. Okay, how many sig figs are in 49.0? Okay. 3. If you take the time to write the 0.0, it must be significant. So 3. How about this one? More than 3. So how many should your answer have?
3.
Okay. And does it round to 1.35 or do we round it? Okay.
No, we did not round.
Okay. What comes after the 5?
A 9.
Okay. So then how would we round that?
1.36.
Good. Okay. And our unit is moles of the calcium carbide. Okay. I want you to try one on your own. Okay. So how far can you do on this without my help? Okay. So how many grams of the C2H2 are produced when you add water to 5 grams of calcium carbide? So you try this all on your own. So how far can you get? And then, of course, in a couple minutes, we'll check. Okay, should we check our work? Yes. Okay, what number did you start with? Okay, 5.00 grams of the CaC2. Then what did you do?
We converted to molar mass.
Okay, so we converted to moles using molar mass. What's the molar mass of the calcium carbide? 0.10.
And yes.
Okay.
Doesn't matter.
No.
Okay.
Okay, and then that's for every 1 mole. Then how did you get from moles of CaC2 to C2H2.
Then we need
Okay, and in this case, what is the mole-to-mole ratio? Okay, so it's a 1 to 1.
yes.
Okay, and then last step, what did you have to convert the C2H2? Okay, moles to grams, and mole had to go on the bottom, so 1 mole of C2H2 on the bottom. And what's the molar mass? 26.0.
0.036.
I thought it was 0.4, everybody. It should be 0.4. Okay, either way, when we round to sig figs, I don't think it's going to matter. Okay, so then when you calculated it, what did we get for our final answer? 2.03. Okay.
So something.
And what's our unit?
Grams. Okay.
Okay, grams C2H2.